Hello all. Welcome to the episode 15th in hexadecimal of Debugging TV Frames program. You can type your questions during this episode. If I can't answer particular questions now, I then post answers on the website debugging.tv. The topic of today's episode is trace message correlation between different software logs. As an example, we use window message tracing and Citrix tool MessageHistory. MessageHistory is a tool that records window messages sent and posted to Windows. For every message, it also records process and thread IDs along window class and title. There are two versions of MessageHistory. One is for recording messages sent and posted to Windows belonging to 32-bit processes and threads, and the other is for 64-bit processes. So for 64-bit Windows, you need to run both versions if you want to cover all messages in the system. By an intercorrelation, we mean the common case when a support or maintenance engineer has several different logs and needs to relate events between them. We model such a situation by launching two copies of Notepad. One is 32-bit and another is 64-bit, and using both versions of MessageHistory tool to record messages related to copy-paste. When we get two log files, we use Excel to blend them together. So now what I do, I run 64-bit version of Notepad, and I also run 32-bit version. And we also run two versions of MessageHistory. So one is 32-bit, I put it here, and the other is 64-bit, I put it to the right. So what I do, I select all messages just to get bigger logs, all types of messages, and then what I do, I start tracing. Then I switch to the first 32-bit version and type hello window messaging, select, and then copy. And then I switch to 64-bit version of Notepad and do paste. Then I switch to both versions of MessageHistory and stop tracing. So what do we have? We have in MessageHistory we have all outputs sorted by process ID and thread ID. And at the end of all this sorted output, we also have bulk output sorted by time. So you see 32-bit window handles, and if we scroll down, actually we see longer formatted 64-bit window handles from 64-bit message history. So what we do now, we copy the log and into corresponding notepad and save as say messages 32, and then we go to 60 for bit, go to corresponding notepad and save as messages 64 text file. So that's it. Then we go to Excel. What we do, we try to blend two log files. Two log files together. Let me see, maybe I saved it to a different file. Let's see. Here they are. So first we open a 32-bit log. So we import it as delimited file, separated by space. Actually, before we do, we're actually interested only in bulk message stream. So we go back to our notepads, and then we search for bulk. So here we have similar what we have from Spy++ and other tools. So what we need to do, we need to remove different formatting and just leave bulk message stream saved by time. And we do the same for another 64-bit log file. So I delete it and saved. So now we go back to Excel and we now open first 32-bit as delimited file separated by space, and I suggest to use time column as text so we could do good sorting for it. And then basically we just do default. And also what we do, we insert another column. Later you would see that we need it for numbering in order to remove some duplicates later on. Actually, you see that some process IDs were badly formatted, so the rule of thumb is to, when you import hexadecimal numbers or whatever numbers you have, is to use text type for particular number fields like process ID and thread IDs. But for our exercise it is not relevant. So what we do the same for another 64-bit log, so delimited. Then we choose space, and we use text for this field. And you see, if we go, we can also choose text for numbers to avoid automatic formatting. So here again, what we do, we insert additional column. So what we do, we now copy 32-bit log. We select and copy it into at the end of 64-bit. Log. So after that, what we do, we number, create a numbering for all these messages. How to do this? So we hit 1, 2, and then we select this column. Actually, better to select till the end. So the first column, we have 14,000 events, and then we go to Fill and choose Series, and then select Autofill. And so we have all numbering now. So what we do now, just I would like to show you, for example, if we are interested in events, we obviously don't need to clutter our trace with window messages that belong to message history itself. So we search for message history. So we see that this is process ID. So what we do, we filter, we select only these messages that belong to this process ID. These messages, window messages, belong to message history application. And what we do, we select and then delete. So you see the resultant trace have gaps. But remember that we had 2 copies of message history. So we search for another message history and find another process with a different process ID, badly formatted here. But what we can do, we also filter these messages, and then we select and delete. So what we have now, trace with more gaps. You see all messages that are related to a message history were removed. And so now we go to data and do remove duplicates. First of all, we select and then remove duplicates. So then all duplicate rows will be removed, and they are exactly empty rows because they don't have unique number. So remember that we put these numbers for the first column A. So we do remove duplicates, and you see how many duplicates were removed. They were all messages sent or posted to message history windows and its child windows. So now we have consolidated trace, and now what we do, we want to do interleaving of both logs, remember that we appended the other log, 64-bit log to 32-bit log, or the other way around. So we have basically two copies, two window logs, one after another, but we want to sort, to interleave lines that were recorded for same time. Sequentially, we need to sort. So we select, and then we do sort, and here we select column A, actually column B, because we need to select by time. So now we successfully blended both logs into one log. And you see 64-bit, – 32-bit lines are mixed with 64-bit lines. So basically we successfully created one unified log from two logs. And finally, because we are interested in copy-paste, what we do, now we try to filter by messages. Actually, where we have messages here. So we try to filter by, for example, all copy and all paste messages. So basically what we get only two lines, and you see what we have copy, and then we have paste. So you see there was copy from 32-bit notepad and paste into 64-bit notepad. Exactly what we did. This is what I wanted to show you. This how to do intercorrelation. Now we go back to our presentation. Here we used the same tool, and the log format was the same, so we didn't have any difficulties. But usually we have different tools with different proprietary output formats, even in the case of CSV or tabulated data files. And so we propose a solution for a common software trace format, and hopefully write something later about this. So here I put references to two correlation trace analysis patterns, and also two links to two tools frequently used today for troubleshooting user interface issues, window messaging, including window messaging. And finally, here we have usual add slide, and one change since the previous 1 week ago is that we plan a free webinar on pattern-based software diagnostics, and then there we discuss its difference from pattern-driven diagnostics. And so thank you for watching this episode. Please later check out the slides and recorded video from Debugging.tv, and the next episode we plan for the 29th of October. So thank you very much again for watching and listening, and see you all in a week. Bye-bye.